All right, good morning and welcome to your crash course review on atoms. So we're going to start with this picture, and I'm going to remind you that, first of all, atoms make up absolutely everything. Elements are found on the periodic table, and an element is a pure substance made of only one type of atom. So for instance, the element carbon is made up of only atoms of carbon, and atoms of carbon have specific characteristics. Specifically, any atom of carbon will have 6 protons, because we learned that protons is what identifies each element. But anyway, we're going to start with this picture, and I'm going to remind you that the nucleus is the dense middle of an atom, and the nucleus is surrounded by mostly empty space, which is the electron cloud where the electrons kind of zip around. Okay, you have most of the mass right here in the nucleus. You have protons and neutrons that reside there, and of course the negatively charged electrons are in the electron cloud. Okay, just a little bit of a reminder about masses of your subatomic particles. A proton and a neutron have a mass of about 1 AMU, or 1 atomic mass unit. So they have about the same mass, and those two are both found in the nucleus, remember. And then you have electrons, which have almost no mass at all. It would take over 1,800 electrons just to equal the mass of 1 proton. Okay? And that's important to remember, because when you calculate the mass of an atom, you do not count electrons because they're so small. You only look at protons and neutrons. Okay. Oh, that's not y'all's bell. That's just the 7:30 bell ringing. All right. Just a little bit of a reminder about some of the things on the periodic table. Remember, each column on the periodic table, each vertical column, especially the tall columns, have a specific number of valence electrons. So column 1 everything has 1 valence electron. Column 2, everything has 2 valence electrons. We don't talk too much about the transition metals because there's no simple rule for us to determine the number of valence electrons for those. Tall column number 3, or 13, or sometimes 3A, has 3 valence electrons, 4 valence electrons, 5, 6, 7, 8 valence electrons, except for helium. Remember, helium is an exception, but we put helium over there because it is unreactive, just like the rest of the noble gases, because even though it has 2 valence electrons, it's in the first energy level, and remember that the first energy level is full with 2. Anyway, but let's zero in on this box right here, where it's giving you the information that's found in each one of these boxes: the atomic number, the chemical symbol, the atomic mass, and of course the element name. Okay? And then we're going to zoom in and talk about this a little bit. All right, atomic number, atomic mass, element name, element symbol. If you are needing to figure out the number of protons or neutrons or electrons, there are some things that you can remember. And the mnemonic that we learned is ape man. Atomic number is equal to the number of protons, and that's also equal to the number of electrons, as long as we can assume that the atom is neutral. And remember, the rule is, unless I tell you differently, or unless the information that you're given tells you differently, assume that the atom is neutral. Okay? So atomic number equals number of protons equals number of electrons. So you look up here, the atomic number is 9. That means that there are 9 protons. And as long as fluorine is neutral, that means that there are 9 electrons also. Then we can use the man portion of the mnemonic device to remember that mass number minus atomic number gives us the number of neutrons. Okay? Or, working backwards, the number of neutrons plus the atomic number, which is the number of protons. Neutrons plus protons gives us mass number. And remember, this number up here with all the decimals, technically that's called atomic mass, and that's like the average mass number for all of the different isotopes of this particular atom. We would need to take that and round it off to the nearest whole number to get mass number. Okay, so for instance, if we were working with it down here, we would say 19 minus 9 gives us 10. Okay. Okay, this is the test that you took way back in the day, back in the fall. And I'm just going to go over a few parts of it just kind of as a refresher and a reminder as to how you can find some of these pieces of information. So for instance, here I have a particular atom drawn. Okay, so I have a specific piece of information about one particular atom. And if I'm given information about one particular atom, then that's what I use. If I'm not given any particular information, just they say that, oh, it's an atom of lithium, or oh, it's an atom of this or that, but they don't really give you a drawing or any specifics, well, then you have to rely on the information from the box on the periodic table. But if you have specific information about a particular atom, you use that instead. All right, so first question here is, what is the mass of the atom that's represented? Remember that mass is protons and neutrons, so this would be 27. The atomic number, remember, is the same as the number of protons, so the atomic number of this one is 13. What is the identity of this atom? Well, it's the number of protons that identifies the element. And it's kind of hard to see because my marker's in the way, but this says 13, and that means that there are 13 protons, and this is an atom of aluminum. Okay, so we go on to the next question, which is number 4. How many valence electrons does this atom have? Okay, we're talking about this particular atom in the drawing, okay? This particular atom has 8 valence electrons, because remember, valence electrons are the electrons in the outermost energy level. Okay, now let me show you why it's important to use the picture when you can, rather than just the general information. Okay, going back way back to this, here's aluminum, and here's the information that we would get if we have to rely on the information from the box in the periodic table. Normally, most of the time, you have 13 total electrons, which would be 2 in the first energy level, 8 in the second energy level, and 3 in the third energy level. Okay, that's if you were relying on the little box from the periodic table and you had to just use the general information. But you notice here that there is no third energy level. Okay, so this is a specific example, so you use this instead. Okay, what has happened is that third energy level has gone away because aluminum, like other metals, tend to give up their outer electrons, and it's given away those 3 electrons. And so now what we're looking at is 8 valence electrons and only 2 energy levels. All right, what is the charge of this atom overall? The charge depends on the charged particles, and the charged particles are protons and electrons. I have 13 protons, but I only have 10 electrons in this picture, okay? So 13 positives, only 10 negatives, that's a charge of +3 because I have 3 more protons than I have electrons. Again, that's different than if we had to rely on the information straight off the box from the periodic table. If we relied on the box from the periodic table, we would assume that aluminum is neutral, 13 electrons and 13 protons, and the overall charge would be nothing or 0. Okay, so really pay attention as to whether you get to use a specific example that gave you specific information about one particular atom, or whether you have to use the periodic table. All right, again, I am still in the same test back here. This time there's no picture, but it is talking about a particular atom. This atom has 15 protons, 17 neutrons, and 18 electrons. Okay. What element is it? Remember that an element is identified by its number of protons, which is also its atomic number. So I know that it has 15 protons, and I go to my periodic table. 15 protons means that it is phosphorus. It's an atom of phosphorus. What is the atom's charge? All right, well, the atom's charge is going to be determined by protons and electrons because those two have a charge. Remember, neutrons have no charge. So I have 15 positive charges and 18 negative charges. So I have 3 more negative charges than I have positive charges. So my charge is -3. What is the atom's mass? The atom's mass is going to be determined by protons and neutrons because remember, they both have a mass of 1 AMU, whereas electrons have almost no mass. So 15 plus 17, this atom's mass is 32. Okay? They gave you a description about one particular atom. That would be different than if you had to use the box from the periodic table, because the box from the periodic table is going to give you this information down here: 15 protons, 16 neutrons, 15 electrons. Okay? And that's not the same as what was given for this particular atom. So just be careful. I'm trying to warn you that you really need to pay attention to when you get to use specific information versus when you just have to rely on the periodic table box. Okay? Okay. I am now on the back of the same test, and I have 4 examples of atoms of different elements. Notice I don't have the chemical symbols, they're just random numbers. I look here, and I notice that I have only 1 energy level, and I have 2 electrons in that energy level. There's no information that I'm given that would lead me to believe that these are not neutral atoms, so we're going to assume that they're neutral, which means that if they have 2 electrons, then this atom also has 2 protons. Well, who has 2 protons? That's going to be helium. So that's an atom of helium. Over here, only 1 proton and 1 electron. That is going to be hydrogen. So these 2 guys are in the same row because they only have 1 energy level. Okay, let's look at D. We have 3 energy levels, 1, 2, 3, 4, plus the other 10, that's 14 electrons. If we can assume it's neutral, then it's also going to have 14 protons. 14 protons tells us that that is silicon. That's in column 4. Over here, I have a total of 6 electrons. If it's neutral, that means I have 6 protons as well. 6 protons tells me that this one is an atom of carbon. Okay? Now, carbon and silicon both have 4 valence electrons, so they will be in the same vertical column. Here they are, carbon and silicon. Okay? Okay, so on each one of these videos, I'm going to go back into Edpuzzle to verify that you watched 100% of the video, even though I did not include, questions in the Edpuzzles. So you'll need to watch the videos. That's part of the credit for the assignment. And then after you have watched this video and any other appropriate videos, you will complete the review sheet and you'll turn it in.